So welcome everybody to this another video on 162 Maths, and in this video we'll be looking at factorising quadratics into double brackets where you've got a single x squared. Now before we get started, let's have a quick refresh on some of the basics. Now, a quadratic expression is where the highest power or degree of a variable or letter is 2 and where you only have one variable is present. So for example, here we've got 8 expressions and we want to work out which of these are quadratic expressions, making sure that they abide by these two rules. So the highest power is 2 and you've only got one letter. So looking at this first one here, you can see that our highest power is x squared and we've already got x's, we've got no other letters, so this is a quadratic expression. Looking at this one here, let's use a different colour. So looking at this, we've got y squared, so the highest power is 2, which is squared, and we've only got one letter, which is y, so that is also a quadratic. Looking at the next one here we can see that our highest power is 2, but we have got 2 letters. We've got x and a y, so that there is not quadratic. Looking at this one here, let's use a different colour pen. So here I've got the highest power is a 2, and I've only can see one letter, which is x, so this is quadratic. Looking at the next one, so here we've got the highest power of x is squared, but the problem is here we've got 2 letters, we've got x's and y's, so that there is not quadratic. Looking at this next one, here we've got x cubed plus x squared plus 4, so even though we've only got one letter, which is x, our highest power is 3, so therefore that is not quadratic. Moving on to the next one, so here we've got our highest power is x squared and we've only got one letter, so that there is quadratic. And then finally for this last one, here I've got brackets, but if I expand the brackets out, then I get 3x squared plus 9x, and here you can see that I've only got one letter, which is x, and the highest power is a 2, so that there is quadratic. Now when you are asked to factorise a quadratic, there are several ways to do this depending on the expression or equation and what the question is asking you to do. Now you can factorise a quadratic by either using a single bracket, using a double bracket, which are both going to be covered in this particular video. You can factorise using a method of difference of two squares or dots, which is covered in another video, which I'll include a link at the end. And also you can factorise by completing the square, or CTS as I like to call it, which again is covered by another video in which I will include links in the description and at the end of this video. Now looking at single brackets first, now this is really rare, and when asked to factorise a quadratic that will only involve a single bracket, but it is not impossible, so just be mindful. And it's important that when you practice these types of questions you'll recognise when something is single brackets and when it's looking like a double bracket question, although they can look very, very similar. So let's have a look at some examples. So here we've got a set of examples that can only be factorised using one bracket. So looking at question 1, so here we've got x squared minus 5x, so here we've got only 2 terms. So that could be a simple sign, but not always the sign that's only going to be single brackets. So here we've got x squared and minus 5x, and the common term within a common factor within these two terms is x. So I take an x out, and then it's going to be x take away 5, and that I factorise the question. So with number 2, I've got x squared and I've got 20x. So again, a common factor there is x. So I've got x plus 20. With number 3, I've got, now here I've got 4x squared minus 16x, so a common factor is 4x. And then working out what do I need to multiply 4x to get 4x squared, well I need another x. And what do I need to multiply 4x to get minus 16x, well that's going to be minus 4. With question 4, I've got 15x squared minus 5, so here I can take out a 5. And I've got 3x squared minus it's going to be 1. And with this number question 5, we've got 10 and we've got a 2x, so I could take a common factor of 2 out, in which I'm going to end up with 5 minus x squared. And then with question 6, I've got 20x plus 5x squared, so a common factor there is going to be 5x, in which I've got 4 plus x, and there is my final answer. Now you do tend to find that these types of questions don't really come into factorising quadratics, with the exception maybe of questions 1, 2, 3 and 6, and the main reason for that is because generally speaking in each of those 4 asterisk sort of example answers I've given you, there is no x squared outside the bracket or inside the bracket. Whereas with the answer to question 4 and 5, you can see that I've got x squared either in the bracket or outside the bracket, which again kind of defeats the object to the purpose of factorising, which then goes on to solving equations. So just be mindful of those types of questions and don't overcomplicate a question that may seem just like a simple factorising question by turning it into something that delves into the quadratic realm. So now let's have a look at double brackets, which is the main theme of this video. Now this video is only going to cover factorising quadratics when you've got a single x squared. It is possible for you to factorise quadratics into double brackets when you've got multiple x squared, but again that's going to be classed as a much higher level, looking at higher GCSE or sort of dipping into AS level. Now when factorising a quadratic into double brackets, which is the most common form that you're going to need to be doing, which is factorising double brackets, we need to find the two numbers that go inside the bracket. So what we're wanting is we end up with something that looks like this, and we want to turn it into something that looks like this. So what we're wanting is two double brackets in which we've got x and we've got plus something, and we've got x plus another number, again being multiplied. Now to calculate these numbers, now again this is the general rule, then what we need to do is we need to find these two numbers such that they multiply to give you c, which is the constant, what we call it. So in other words, the thing that hasn't got a number, which is here, and which is the most important thing, we want to find the same two numbers that add together to give you the coefficient of x, which is what we call the b value. So for example, if I had x squared plus 6x plus 18, then what I'm looking for is I'm looking for two numbers that multiply to give you 18 but added together to give you 6. And that's how you get it. Now just be mindful that try not to think about it as two numbers that multiply to give you the number at the end, because sometimes you might get a quadratic where things are flipped. So for example, you could get something like that looks like this, when really you want two numbers that multiply to give you the number but added together to give you the number of x's. Now if you find that there is no number in front of your single x, then it's always going to be a 1. So x is just 1x and minus x is minus 1x. So just be mindful of that. Now to gain some practice of this, I encourage you to complete the worksheet in the description. Now in this particular description, what we've got to complete this sort of pyramid or brick wall, whatever you see it as. Now here what we've got a number that we need to find that multiplies to give you the top number but added together that gives you the bottom number. So what I want to do is I want to find two numbers that multiply together to give me 14, but the same two numbers need to add together to give me 9. Now I always recommend that you start with the multiplying one first. I always think that, because there isn't going to be an infinite number of combinations that you can add two numbers together to give you 9, whereas there's only going to be a certain number of numbers, whole numbers I should say, that multiply together to give you 14. So for example, I've got 1 and 14 would give me 14. I've got 2 and 7, and that's pretty much it. So using a combination of these numbers, which I know will definitely work for this. Now not any of those two numbers, but just either this combination or this combination. Which two cards could I use to make 9? Well, the answer is going to be 7 and 2. So my numbers I'm going to put here are 7 and 2. For question 2, I want to find two numbers that multiply together to give me 18 and added together to give me 9. Again, think to yourself, start with 18. So what numbers multiply to give you 18? So I've got 1 and 8, 2 and 9, 3 and 6. I'm thinking, okay, which of these sets of numbers could I use to make 9? It's going to be 3 and 6. So I've got 3 and 6, 3 and 6. Now it doesn't matter which order you put them in. I'm going to put 6 and 3 and job done. For question 3, again, I want to try and find two numbers that multiply together to give me 28, but added together give me 11. So again, always start with the multiplying. So I've got 1 and 28, 2 and 14, 4 and 7, and I think that's pretty much it. So looking at these pairs of numbers, which of these numbers could I use that add together to give me 11? Well, it's going to be 4 and 7. 4, 7, 4, 7. So I've got and 7 there. And put it in different order, just to emphasize the point that doesn't matter what order you're putting them in. So for the last one here, for number 4, we've got to find two numbers that multiply together to give you 36, added together to give you 13, in which your two numbers there are going to be, well, 36 is either going to be 1 times 36, 2 and 18, 3 and 12, 4 and it's going to be 9 and 6 times 6. So looking at these, which pairs of numbers would give me 13? It's going to be these two here. So I've got 4 and 9, 4 and 9. So I put 4 and 9 here. And again, there will be some practice on this. Now, how this actually relates, you might be thinking, how does this relate to factorising quadratics? Well, let me just explain to you how this all works and why this particular worksheet will help you make things a little bit easier in terms of understanding what it is you've actually got to do. So, for example, this yellow number, these yellow numbers are basically going to act as your seed. So that's going to be the number that we have at the end. So with question 1, I've got x squared plus, and it's going to be 14 here, and it's going to be 9 here. It's going to be 9x. So this is where the numbers go. So here is your 9, here's your 14, and that's going to equal x plus 7, x plus 2. With question 2, I've got x squared plus, and it's going to be 9x again, plus 18 equals, and again, from these two numbers, so that there is this number here, 18 is the top number in the yellow, and what does this equal? It means that these two numbers here are going to be the numbers inside my bracket. So I've got x plus 6, x plus 3, and it doesn't matter what order you put those numbers in, that's going to be absolutely fine. So for number 3, I've got x squared plus 11x plus 28. And again, the two numbers that are going to go inside my bracket are going to be these two numbers. So I've got x plus 7, x plus 4. And then finally with question 4, I've got, if the question was x squared plus 13x plus 36. Again, these numbers, this number comes from that box there, and that number comes from that number there. And so here my two numbers are going to be x plus 4, x plus 9, or again you can write it as x plus 9, x plus 4. They're both going to be absolutely correct. There's going to be no question about that. So let's have a look at these examples without using a grid or a sort of tiles. So looking at question 1, I've got x squared plus 14x plus 45. So what I want to do is I want to try and think of two numbers that multiply to give you 45 but added together to give you positive 14. Now with these, it is important that you include the signs, because obviously we will slowly move on to negative numbers, but again the policy is this. Now this is not something you will have to write in your working out. This is something that you eventually could, and with practice you will be doing in your head. But just to get started, if you always find this topic particularly difficult, I strongly recommend that you do have these things written down. So again, what you always want to start with is the thing being multiplied. So you think, okay, what numbers, two numbers multiplied together give you 45? Well, I've got 1 and 45. I've got 3 and 15, and I've got 9 and 5. And so what you will then want to do is, once you've got your pairs of numbers, you think, okay, which pair would give me positive 14 if I use those two numbers? So here we're looking at the most, or the one that should ring alarm bells is going to be 9 and 15. So we've got 9 and 5, sorry, 9 and 5, not 9 and 15. And so what the two numbers in the brackets are going to be 9, and 1 is going to be 5. And there is my factorised answer. Number 2, we've got x squared plus 13x plus 36. So again, what I want to think about is two numbers that multiply to give you 36 but added together to give you 13, positive 13. So looking at 36, well, I've got 1 and 36, I've got 2 and 18, I've got 3 and 12, I've got 4 and 9, and I've got 6 and 6. So from this, what I'm going to do is try and think of, okay, which pairs of numbers would give me 13? Well, it's going to be this pair here. So then my brackets, the numbers inside the brackets are going to be x plus 4 and x plus 9. Again, if you decide to put those brackets the other way around, that's absolutely fine. So for question 3, I've got x squared plus 3x minus 18. Now, this is where we need to be a little bit careful, because we now have negative numbers in place. Let me just get rid of all this so we've got a bit more room. But the method is exactly the same. If I look at this number here, so get a pen that you can actually see, 18, I want to try and find two numbers that multiply to give you 18 and I can use to get positive 3. So this is the sum that I want. Positive 3. So looking at the numbers that are multiplying, I've got what numbers multiply to give you 18. Now don't worry about the negative just yet. So what numbers multiply to give you 18? Well, I've got 1 and 18. I've got 2 and 9. I've got 3 and 6. And that's pretty much it. So looking at these numbers, how can I use these numbers to make my positive 3? Well, 1 and 18, well, if I add them together, I'm going to get 19. If I take them away, I'm going to get 17. So this I can either make 19 or 17, because obviously one of them is going to be negative, because I can use negative numbers to turn it into a subtraction. For 2 and 9, well, either I can make 11 or I can make 7. And for 3 and 6, well, either I can make 9 or I can make 3. And it's the 3 that I want, so it's going to be this pair. So looking at these numbers, I've got x and I've got 6 and 3. Now because I want positive 3, then what I'm going to need to do is 6 minus 3. So my minus is going to be the 3 and my positive is going to be the 6, and there is my final answer. For question 4, which I'll do over here, I've got x squared plus 3x minus 54. So again, looking at minus 54, what two numbers multiply together give you 54, let's say. Let's ignore the minus to begin with. Well, I've got 1 and 54. I've got 2 and 27. I've got, it's going to be 6 and 9. And that's pretty much it, I'm thinking. I'm sure 3 would go into it. I've got 3 times, and it's going to be 2, 1. And it's going to be 8. So 3 times 18. Can I divide 4? No, I think that's pretty much the combinations that I've got. So looking at these pairs of numbers, is there ways I can make 3? So here, using this pair, I can either make 53 or I can make 55. With this pair, either I can make 29 or I can make 25. With this pair, I can either make 15 or I can make 3. And again, here I've got my 3, so it's going to be using these two numbers. So here I've got x, 9, x, and 6. Now because I want positive 3, while using 6 and 9, how can I make positive 3? Well, it's going to be 9 take away 6. So the 6 is going to be minus, and the 9 is going to be positive, and there is my final answer. Then moving on to question 5, I've got x squared minus 6x minus 40. So again, thinking of two numbers that multiply to give you 40, well, I've got 1 and 40, 2 and 20, I've got 4 and 10, I've got 8 and 5. So looking at these, what combinations I could make? Well, with this first pair, I can either make 39 or 41. With this, I can either make 22 or 18. With this, I can either make 14 or 6. So it's going to be that pair there. So my two numbers are going to be 4 and 10. So using 4 and 10, how can I make minus 6? Well, I can make minus 10 by doing 4 take away 10. So the minus is going to be with a 10 and the 4 is going to be positive, and there is my final answer. So what I recommend that you do is have a go at these questions, and I'll just run through the answers of what you should have. So if you want to pause the video and have a go at these using the method I've just gone through, and then we'll go through the answers. So if you've factorised these correctly, let's just go through the answers. So for question 6, you should have x plus 3 and x plus 4. And again, if you've got the 3 and the 4, and let's say x plus 4 first, that's still going to be correct. So that's absolutely fine. For question 7, you should have x plus 9, x plus 2. For question 8, you should have x, and looking at the numbers, you should have 10 and 2, and we're looking at positive 10 and minus 2. For question 9, we're going to have 9 and 7, and you should have -9 and +7. And finally for question 10, which is a little bit tricky, you should have 2 and 2, and both of which are minus. There we go. Now once you've mastered that skill, there are a couple of things that you can notice. And so if C is positive, now what I mean by C is this number at the end with that what we call the constant that's got no letters attached to it. So if C is positive, then the two numbers you select will have the same sign. So either the two numbers in the brackets will both be positive or they will both be negative. Now if C is negative, however, then the two numbers you select will be different signs. So one will be positive, one will be negative, and you've just got to decide which one. Now in terms of B is always the same sign as your bigger of your two numbers that you've selected. So if you are struggling to decide, right, okay, do you know what, I'm getting the numbers, I can't get my head around the signs of the numbers, well then making a note of this will come in handy. And again, if you're struggling, definitely include this in your revision notes or in your revision posters that you decide to collect when working through these particular questions. So let's put into practice this new technique. So looking at question 1, we've got to factorise x squared plus 10x plus 21. So again, what I'm looking for is two numbers that multiply together give me 21 and added together all with a difference of +10. So again, looking at the numbers and thinking of the numbers, what number more numbers multiply with 21 that I can make 10 with? That's going to be 7 and 3. Now looking at this first symbol, that is always going to be the symbol of your bigger number. So in this case, it's going to be the 7. And this, because this symbol is a plus, it means that the signs are going to be the same. So therefore, that must also be a plus. Looking at question 2, again, once you've decided what numbers to choose, so in this case, I'm looking for two numbers that multiply together give me 18, where a difference of 7, or added together give me 7, and that's going to be 9 and 2. So again, looking at this, because this is a plus, it means the bigger the two numbers is going to be a plus, so that's going to be a plus, and because this is a negative, it means the signs are going to be different, so that means it's going to be a negative. Looking at question 3, now this one is also known as a dots question, which again is covered in another video, but again here we're looking for two numbers that multiply to give you 36 with a difference or a sum of 0, and that's going to give you 6. Now here we haven't got a symbol in front of the x's, so we've got no b in this question. So this symbol here is the symbol of the constant or the symbol of the c, which is negative, so therefore it means that the signs are going to be different. And then finally, with question 4, I'm looking for two numbers that multiply together give me 50, but added together or with a difference of 27. So here I'm looking at 25 and I'm looking at 2. So again, this symbol here means that the bigger of the two numbers is going to be negative, and this symbol here, as it's a positive, means they're both going to be the same, so that's going to be a plus, and there is my final answer. Now we'll include some practice questions and their answers in the description below for you to practice everything that's covered in the video. Now in terms of extension, the next step would be to investigate things like completing the square and other techniques of factorising, but also factorising quadratics where you've got multiple x squared. So an example of that would be when you're asked to factorise, let's say expressions that have got 2x squared plus, let's say 10x plus 8. In which this divide means you need to use a completely different technique for you to factorise these questions, which again I will include a link at the end of this video for you to click on.